Hey, so welcome to 8.5. We're going to be graphing a sine wave and a cosine wave today using the unit circle and using those special right triangles. So one of the things that we want to pay attention to is that sine is going to be opposite over hypotenuse. So when we graph this, we're dealing with the height of the triangle over the radius or over the hypotenuse. In which case, if we have a radius of 1 for the unit circle, we're simply dealing with the height of the triangle. With cosine, cosine is adjacent over hypotenuse, CAH. So we're dealing with the base of the triangle. If we have a triangle, we're dealing with the adjacent side over the radius, which is going to be over 1. So we're simply dealing with the x value on the triangle. So let's go ahead. I've created an animation where we can take a quick look at that. Let's zoom over to that before we begin. Okay, so we're going to take a quick look here at an animation that I've created to kind of show you what we're talking about. Traditionally using an x and a y axis with a series of triangles, all with hypotenuse of 1, meaning that yellow line is equal to 1 on all of these triangles, we create a circle using the endpoints. So that far aspect creates a circle. Well, not everything benefits being graphed in a circle. Sometimes we want to see what happens as we change that internal angle. So let's take a quick look. If I slow this down, what happens instead of using an x and a y, I graph the height of this triangle, so this gray value, based off what the internal angle is. So how many degrees or how many radians is sitting right there in the center. So I'm going to figure out the height of each one is going to be my y, and that internal angle is going to be my x. And so we're going to let this one finish, and we're going to jump over to what that would look like. Okay, here we go. Maybe that was a wee bit slow. So what's going to happen is we're going to create something called a sine wave. And now I've gone ahead and I've put down the different parts of the circle. This would be 90, 180, 270, and 360 degrees in radians. So what would happen if we took that same triangle and instead of graphing it in a circle, we graph the height of the triangle as a measurement of each degrees? Well, it would look something like this. And you see the fact that we're still circling our way around, but we're moving over in relation to that internal angle of the triangle. Let's slow this down a little bit more so we can see that. So based off the angle that's in that triangle, that's the value where we're placing this height. So right now when that angle is 90, our height is of 1. And when we get down here and that internal angle is at 0, well, we're at 180 degrees. And we work our way all the way through. And now, albeit each of these animations are useful, let's take a quick look at what they look like side by side. And there we go. So here's a quick animation where I've put them side by side. You can see as we work our way around the circle, we're creating this sine wave using, again, the endpoints of the triangle, and each time we move over is each time we increase that angle inside the triangle. So here's a quick way to see. As we continue to increase that angle as we work our way around using the yellow bar, we're working our way down the x-axis. And as we go up, our graph goes up. And as we come down, our graph goes down. And so I'm going to play this one more time just so you can watch it. I'm going to slow down the speed just a little bit. And now this would be a good time to, if you want to just pay attention to the relationship between the unit circle and the sine wave, pause the video and watch this. So today we'll actually need graph paper. And let's go ahead and let's label this. I believe we're on 8.5, which is graphing sine and cosine. So now graphing sine and cosine. As you saw in the animation, what we were doing is we're going to be graphing the sine wave with our x value being the degrees and our y value being the height. Because sine is graphed x as degrees or radians and y as height. So that's how we graph our sine, because sine is so, right? SOHCAHTOA. Now with cosine, how do you think we're going to graph our x and our y? Knowing that of SOHCAHTOA, so is ka. What do you think the x is going to be? Well, yeah, it's still going to be degrees and radians. Or radians. But y this time, because we're dealing with the adjacent, is going to be not the height, but the length. And so that's where that comes from. And we're going to graph tangent in the next section, but we're going to start with just sine and cosine. So I think the first good example is, let's go ahead and graph y equals the sine of x. And that's what we're going to do. So let's go ahead and let's graph that. Now our first thing that we're going to do is we're going to make an x and y table. Okay, and so I know that my x value, if we look back at it's opposite over hypotenuse. And so I know that from that given example, my opposite is my y over my hypotenuse, which is my radius. And the radius of a unit circle is equal to 1. So it's just the y value of that triangle. So let's go ahead and let's figure out what my y values are at different degrees. Now, this is why we went over the unit circle and used the special triangles, because if I just listed 1, 2, 3, 4, I'm going to be plugging into the calculator every single time. And that takes a lot of typing, takes a lot of effort, so why not just go with the basic triangles? I'm going to say 0, let's see, with a sine, let's say 45 degrees, 90 degrees, 135, 135, 180, 225, 270, 315, 360. Now, I use degrees right here. Another way that we could do this is we could do this with radians, and we would just plug in the equivalent of each radian. So that would be, if this was radians, I would have, do it in a different color. I would still have 0, but this would be pi over 4, pi over 2, 3 pi over 4, pi, let's see, 5 pi over 4, 3 pi over 2, 7 pi over 4, and 2 pi. So it doesn't really matter which unit we use, but we're going to be graphing the entire circle. And now let's see, at 0 degrees, what is the height of a triangle when that line is all the way? It has no height. And we know at 90, it has a height of 1. And once we've flipped all the way around at 180, we have a height of 0 again. 270, it is at the bottom of the circle. And 360, we've come full circle. Now, where did we get these numbers? Well, we got these numbers based off of, like I said, as we work our way around. We know the y value at 0 is 0, then it's 1, 0, -1, 0. That's where we got these. And the y value of this, if we remember our 45, 45, 90 triangle, if we know we have a radius of 1, we're going to have, I believe that was 1 over the square root of 2. 1 over the square root of 2. Or if we were to write that in a more proper term, that would be the square root of 2 over 2. However, to make our lives a little easier, we're going to plug that in as a decimal. And so we know that the square root of 2 divided by 2 is going to give us 0.71 roughly. So that's 0.71. Same thing over here, we have 0.71. And when we hit this angle, it is a negative 0.71. And again over here, it's a negative 0.71. And we're going to graph these values on an x and a y axis and see what shape they make. So this is my y. This is my x. I need to get up to 360. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. I need 8. So I'm going to do about every 2. 2, 3, 4, 5, 6, 7, 8. And so this is either going to be 360, or I'm going to double label this 2 pi. So that way, if you want to do radians, I have the radians on here. If you want to do degrees, I have those on here as well. 45. Okay, so let's go ahead and let's list. We need to go up to 1 and down to negative 1. So I'm going to say this is my 1, and this is my negative 1. Awesome. And so now let's go ahead and let's graph our graph. And we're going to do this in, let's say, orange. So I know at 0, I have a height of 0. At 45 degrees, as I've worked my way up, my height is roughly to 0.71. So I'm going to go up to roughly 0.71. At 90, I've gone all the way up. And then I'm starting to come back down. And at this point, I hit 0 again. Negative 0.71. Negative 1. And boom. And there we go. We have our first official sine wave. That is y equals the sine of x. Awesome. So now let's graph a second one. Let's graph, instead of the sine of x, let's graph the cosine of x and see what that does. So our second example is graph y equals the cosine of x. And now again, we're going to be using the same set of features as we did on the sine wave. I'm going to graph an x and a y. And now again, we could pick any values for x, but it's easiest to pick the special right triangles, either the 30, 60, 90 or the 45, 45, 90. I like the 45, 45, 90 because it gives me even increments that aren't too close together. If I did 30, 60, 90, I would have one here and one here, and it would just be a lot more plotting. This table would be a lot bigger. So I'm going to go ahead and I'm going to stick with 45, 45, 90. And remember, these are in degrees. If you wanted to do it in radians, it also works out. So my radians would be 0. Awesome. So we have these. Now what we're going to do is we're going to go ahead and we're going to get our graph set up. And then if I wanted that in radians, I would just list those as well. Awesome. there we go. I have my unit of 1, my unit of -1. And so let's again think about cosine. Now, cosine we said was adjacent over hypotenuse. And when I deal with that, that's always going to give me my adjacent side, which is my x value, over my hypotenuse, which is my radius. So it's always going to be x over r. Because the unit circle r is 1, it's just going to be my x value. So instead of being like this, where we're dealing with the heights of the triangles, here we're seeing how wide the triangles are. So we're not necessarily going to start at the same point. I'm going to quickly draw my unit circle up here just so I know how to check. Well, at 0, my x value is all the way over. It's all the way over at the very, very end, so I know my x value is 1. And as I go up, now I'm at my 45, 45, 90 triangle, which is 1 over the square root of 2, 1 over the square root of 2, which we said that is equal to the square root of 2 over 2, which is 0.71. So 0.71 divided by 1, which is just 0.71. And as we hit the very top at 90 degrees or at pi over 2 radians, we know that the x value doesn't exist because it's a vertical line, so 0. And here my x started to go negative. So here I have a negative 0.71, a -1, because we've reached the back of the circle. And as we keep going around, my x is still negative. And then I hit 0 because at 270, again, my x does not exist. And then it becomes positive at the very end. And so let's see what this looks like on the graph. So if I plot 0, 1, okay, we get the basic shape of our cosine graph. And now we notice that it looks very, very similar to our sine wave, except for our sine wave, if we look at that, starts at the lowest part, I see it arc up and down and up. I would see that same feature if I started my cosine wave a little bit behind. I'd see that upward curve and that downward curve. But instead, we're starting at the peak of our sine wave, and we notice the shapes are identical if we follow the sine wave just a little over from where it started. So if I start here, my cosine wave and my sine wave are identical. And that's the basic function on how to graph sine and cosine. Okay, so we saw how the sine and cosine waves looked very, very similar. It looks like they almost just started at a different point. So they do the same thing, but again, they start at different points in the graph, so they have a little bit of a different look to them. But remember, sine wave deals with, out of the 3 parts of the triangle, is opposite over hypotenuse, so we're dealing with the y value of the special right triangles in that unit circle. And with cosine, in our unit circle, we're dealing with adjacent over hypotenuse, so we're always dealing with the x value of that triangle on the unit circle. So that being said, if you have any questions, let me know.